Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about adjoint matrix and inverse matrix. So student, let's go adjoint matrix. What do you mean by adjoint matrix? Adjoint matrix, an adjoint matrix is a square matrix formed by interchanging rows and columns of a cofactor matrix. It is denoted by adjoint of A. I say again student, what do you mean by adjoint matrix? An adjoint matrix is a square matrix formed by interchanging rows and columns of a cofactor matrix. Then it is denoted by adjoint of A. Look at the board student. It is denoted by adjoint of A. Adjoint of A. Now to find adjoint matrix, let A is a matrix. Here A, B, C and D. Now find adjoint matrix. So student, this is 2 by 2 matrix, 2 row and 2 column. This is 2 by 2 matrix. Now cofactor of A, cofactor of A, it is denoted by A11. Here matrix A, here entry A, position first row and first column. So it is denoted by A11. First number indicates the number of row and second number indicates the column. Now student, cofactor of A is -1 whole to the power number of row plus number of column. Now here first row and first column are cancelled, then minor is D. So student, power even number, so -1 whole square is positive and D, so positive. So student, attention please, here number of row and number of column, sum of number of row and number of column is even number, so cofactor is positive sign. Again student, cofactor of B, cofactor of B. Now here it is denoted by A12. This is entry B, position first row and second column. It is denoted by A12, first row and second column. Now we have -1 whole to the power number of row plus number of column. So number of row and number B is first row and second column are cancelled. So minor is C. So student, here -1 whole cube is minus, so C. So here attention please student, sum of number of row plus number of column are odd number, so this is sign is minus. Similarly, cofactor of C, cofactor of C, it is denoted by A21. Here second row and first column, it is denoted by A21. So -1 power rest of power 2 plus 1. So here first column and second row are cancelled, so minor is B. So student, here power is odd number, so here negative values minus B. I say again student, last one, cofactor of D, it is denoted by A22. So -1 whole to the power 2 plus 2. Here D is Here D is position of D, second row and second column. So second row and second column cancel. So minor is A. Now we have cofactor is minus 1 whole to the power 4. 4 is positive number. So sign is positive. So student, attention please. Number of row and number of column. Sum of number of row and number of column are even number. So cofactor is positive. Similarly, number of row and number of column are negative. Sum of number of row and number of column are negative. So cofactor is negative. So student, this is very important thing. Now we have adjoint matrix. So by the definition of adjoint of A equals to, here cofactor A11 is D and minus C, then minus B and A and transpose matrix. This is cofactor matrix whole to the power transpose T matrix. So we have, and changing column convert to row. So D minus B and minus C A. This is adjoint matrix. So I hope that student you are clear. But shortcut method, these short tricks. So attention please student, short tricks. Again, short tricks for MCQ. Only for MCQ. Now here matrix A equals to AB and CD. So adjoint matrix, adjoint of A equals to, here diagonal, principal diagonal, interchanging the two entry. This is 2 by 2 matrix for 2 by 2 matrix for MCQ. So here interchanging principal diagonal, entry of principal diagonal. So here D and here A and other entry C and D. Here opposite side C and B. So this is positive, so negative, and C is positive, so becomes negative. So student, this matrix and this matrix are equal. So this is short tricks and this is usual tricks. So I hope that student you are clear. Student, another example, adjoint matrix. To find adjoint matrix, now we have let matrix A equals to 1, 2, 3, 4. Find the adjoint matrix. Now cofactor of 1, it is denoted by A11, first row and first column. So student, here sum of number of row and number of column are even number, so here positive. Then we have 1 plus 1 number of row and number of column. So here first row and first column, first row and first column are cancelled, so minor is 4. So student, number of row and number of column are cancelled, so minor is 4. So here power number of row and number of column are your even number, so this is positive. Positive means 4. Again, cofactor of 2, it is denoted by A12. Here position of 2 is first row and second column, so it is denoted by A12, first row and second column. So sum of number of row and number of column is odd number, so cofactor, sign of cofactor is negative. So student, here minus 1 whole to the power 1 plus 2 into first row and second column are cancelled, so here minor is 3. Now cofactor is minus 1 whole to the power 3 is minus 3. So attention please student, this is A12, position of 2 is first row and second column. So sum of number of row and number of column are odd. So cofactor is negative. So power odd number, so this is negative, and power even number, so this is positive. Similarly, cofactor of 3, it is denoted by a to 1, so minus 1 whole to the power 2 plus 1, and this is number of cofactor of 3. So position of cofactor of 3 is first, second row and first column. So second row and first column are cancelled, so minor is 2. So student, here cofactor, this is number of row and number of column are odd number, so minus 2. Again student, last one, cofactor of 4, it is denoted by a to 2. Here position of 4, second row and second column, second row and second column. Position of 4 is second row and second column. Now we have minus 1 whole to the power 2 plus 2. Attention please student, here number of row and number of column, sum of number of row and number of column are even number, so cofactor is positive. Now we have position of 4, second row and second column, so second row and second column cancel, so here minor is 1. Now cofactor is plus 1. So by the definition of adjoint matrix, now we have adjoint of A equals to, here cofactor transpose of cofactor matrix. Here first entry 4, second entry minus 3, third entry minus 2, and fourth entry positive is 1. It is transpose. So adjoint of A equals to, now interchanging row and column, row or column, so interchanging column, so 4 minus 2 and minus 3 1. This is adjoint matrix. So this is adjoint matrix. I hope that student you are clear. Now this is short tricks, and short tricks for MCQ. For MCQ student, attention please, short tricks, only 5 seconds. Now matrix is, given matrix A is 1 2 and 3 4. Now adjoint matrix for MCQ, short tricks, adjoint of matrix A. This is here principal diagonal, entry of principal diagonal is interchange, so 4 here 1 and other entry 2 and 3. 2 is positive, so here negative, and 3 is positive, so opposite side is negative. So student, only 5 seconds it is completed. So I hope that student you are clear. I say again, student, what do you mean by adjoint matrix? An adjoint matrix is a square matrix formed by interchanging rows and columns of a cofactor matrix. It is denoted by adjoint of A. Student, inverse matrix. What do you mean by inverse matrix? A matrix is formed by dividing an adjoint matrix of a non-singular matrix A by its determinant A is called inverse matrix, inverse matrix of A. So student, let's go look at the board. Here matrix A, let A matrix A. So inverse matrix, it is denoted by A inverse equals to 1 by determinant of A adjoint of A. this is definition of inverse matrix, where determinant of A not equals to 0. This is non-singular matrix. A is a non-singular matrix. Find inverse matrix. For example, let A is a matrix. Let A is a matrix 1, 2, 3, 4. Find inverse matrix. Now we have student. By the definition of inverse matrix, we know that A inverse equals to 1 by A as determinant A adjoint of A. Now we have find the determinant of A. So student, here determinant of A is 1, 2, 3, 4. Here 1 into 4, 1 into 4 minus 2, 3 into 2 equals to 4 minus 6 equals to minus 2. 4 minus 6 equals to minus 2. So A not equals to 0. So A inverse exists. So this is matrix A is non-singular matrix. Now we have adjoint of matrix A. Here adjoint of matrix A is cofactor. Now find cofactor. Here cofactor of 1 is 1 A11. Cofactor of 1 first row and first column. So here first row and first column are even numbers. Sum of number of row and number of column is even. So here positive. First row and first column are cancelled. So minor is 4. So A11 is 4. Similarly, cofactor of 2, it is denoted by A12. This is first row and second column. So first row and second column, or first row, sum of number of row and number of column are odd number. So cofactor is negative. So first row and second column are cancelled. So 3. So cofactor is minus 3. Similarly, cofactor of 3, it is denoted by A21. Here A21 means 3, position of 3, first column and second row. First column and second row. So here number sum of number of row and number of column are odd number. So here negative. So here first column and second row are cancelled. So minor is 2. Now cofactor is minus 2. And similarly, find the cofactor of 4. So it is denoted by A22. So cofactor of 4, number of row, second row and second column are cancelled. So minor is 1. And here number of row and number of column, sum of number of row and number of column are even number. So this is positive. So adjoint of matrix, by the definition of adjoint matrix, equals to, here number 4 minus 3 minus 2 and 1 transpose matrix. This is cofactor matrix by cofactor matrix to the power T transpose matrix. Now interchanging row or column. Now column will be row. So 4 minus 2 minus 3 1. This is adjoint matrix. Now student, by the definition of inverse matrix, so we know that A inverse equals to 1 by determinant A and adjoint of A. Now putting the value of 1 by A is minus 2 and adjoint of matrix minus 4 minus 2 minus 3 and 1. This is inverse matrix. So student, attention please. Here first find the value of this determinant and find the cofactor, then adjoint of matrix, then A inverse is 1 by minus 2 4 minus 2 minus 3 minus 1. So value of A inverse is 1 by minus 2, 4 minus 2 minus 3, 1. I hope that student you are clear. So student, we know that by the definition of inverse matrix, so we have A inverse equals to 1 by determinant of A adjoint of A by the definition of inverse matrix. Now putting the value of A, determinant A is minus 2 and adjoint matrix 4 minus 3 minus 2 and 1. So required A inverse equals to 4 minus 2, 4 minus 2 minus 3 minus 1. So it is inverse matrix. I hope that student you are clear. Another example, find the A inverse. Find A inverse. So let's go student. It is 3 by 3 matrix, 3 row and 3 column. Now find the A inverse. So student, look at the board. Let A matrix 2 minus 1 3 1 2 0 1 0 1 find A inverse. So student, now find determinant of A. So student, here A equals to determinant of A. So 2 minus 1 3 1 2 0 1 0 1. Then find the value of determinant of A. So student, here then first element is 2. So 2 is first row and first column. So first row and first column are cancelled. Then we have 2 0 0 1. Then student, here first element 2 and then minus 1 first row and second column. So position of 1 first row and second column. So first row and second column cancel. Then rest of the number minus 1 3 0 1. Then plus 1. Now student, here position of 1 is first row and third column. Now we have minus 1 2 3 0. This is 2 is plus first element, plus minus and plus. Now we have 2 into 1, 2 minus 0 into 0 means 0, minus 1 into 1 minus 1, then minus 3 into 0 is 0, plus 1 into minus 1 into 0, 0, then minus 3 into 2 is 6. So student, here 2 into 2 minus 1 plus 1 into minus 6. So 4 plus 1 minus 6. So 5 minus 6 equals to minus 1. So student, value of determinant is minus 1. So here A, determinant of A not equals to 0. So A inverse exists. A inverse exists. So this is A is a non-singular matrix. A is a non-singular. A is a non-singular matrix. So A inverse exists. Here determinant of A is minus 1. Then find adjoint of A. So student, let's go find adjoint matrix. Look at the board. First, find cofactor of all entry. Now student, here first entry, position of first entry, first row and first column, it is denoted by A11. A11. So sum of number of row and number of column are even number, so cofactor is positive. So A11 is first row, first row and first column are cancelled. So rest of entry is 2, 0 and 0, 1. So student here 2 into 1, 2 minus 0 equals to 2. Again A1, 2, first row and second column. Position of 1 is first row and second column. Here it is denoted by A1, 2. So first row and second column are cancelled, and here minus, because 1 plus 2 is 3, so cofactor is 3. Here first row and second column cancel, so rest of entry is minus 1, 3 and 0, 1. 0, 1 equals to minus 1 minus 0 equals to 1 and position of third entry is 1, 3 equals to 1 plus 3 is 4, so positive, cofactor is positive. So third row, first row and third column are cancelled, then rest of entry minus 1, 3, 2, 0. So student here 1, 3 minus 0 minus 6 equals to minus 6. So student here A11 is 2, A12 is minus 1 and A13 is minus 6. This is cofactor. Similarly, find cofactor of minus 1. Position is A21. Here second row and first column. So second row and first column are cancelled. Then we have 2 plus 1 is 3. So minus, cofactor is minus. Second row and first column cancelled. Rest of entry 1, 0, 1, 0 and 1, 1. 1, 0 and 1, 1. So we have minus 1 into 1 minus 0 equals to minus 1. And A2, 2, second row and second column. So cofactor of second row and second column. So second row and second column are cancelled. So rest of entry is 2, 3, 2, 3 and 1, 1. 2, 3 and 1, 1. Here second row and second column cancel. Rest of entry 2, 3 and 1, 1. Then we have 2 minus 3 equals to minus 1. 2 minus 3 equals to 1, 1. And last one A2, 3. Here 2 plus 3 is odd number, so cofactor is negative. Now we have rest of number. Position of 0 is second row and third column. So rest of entry 2, 3, 2, 3, 1, 0. So student here minus 0 minus 3 equals to only 3. Minus minus plus. Similarly, student now find cofactor of third row. It is denoted by A31. Position of 3 is third row and first column. So third row and first column are cancelled. Then rest of entry, here 3 plus 1 is even number. So entry cofactor is positive. Third row and first column are cancelled. So rest of entry 1, 2 and 1, 0. So we have 0 minus 2 equals to minus 2. Similarly, position of 0, A32, third row and second column. So third row and second column cancel. Then we have entry is here minus 3 plus 2 is 5. Third row and second column cancel. So rest of entry 2 minus 1 and 1, 0. Here student 3 plus 2 is 5 is odd number, so cofactor is negative. Now we have 0, minus 0 plus 1 equals to 1 equals to minus 1. 0 plus 1 equals to minus 1. And last one, A33, last entry, 3 plus 3 is even number, so cofactor is positive. Number of row and number of column, sum of number of row and number of column are positive. Positive, no? Number of row and number of column are even numbers, so cofactor is positive. So we have third row and third column are cancelled. So rest of entry is 2 minus 1, 2 minus 1 and 1, 2. So student, 4 plus 1 is 4 plus 1 is 5. So student, here this is cofactor, and we know that by the definition of adjoint matrix. So adjoint matrix, student, here adjoint equals to cofactor, transpose of cofactor matrix. Transpose of cofactor. Cofactor A11 is 2, A12 is 1 and A13 is minus 6. A21 is minus 1, A22 is minus 1 and A23 is 3 and A31 is minus 2, A32 is minus 1 and A33 is 5. Now we have interchanged the row and column. So column interchange the row, column interchange the row. So we can write student, column interchange the row, column form the row. So 2 minus 1 minus 2 and 1 minus 1 minus 1, then minus 6, 3 and 5. So this is adjoint matrix. This is adjoint matrix. First column convert to first row and second column convert to second row and third column convert to third row. This is adjoint matrix. By the definition of inverse matrix, we know that A inverse equals to 1 by A determinant of A, adjoint of A. Now putting the value of A is minus 1, determinant of A is minus 1 and it is adjoint matrix 2 minus 1 minus 2, 1 minus 1 minus 1, minus 6, 3 and 5. Now student, multiplying all entries minus 1, then we get minus 2 minus minus plus 1 minus minus plus 2 and minus 1 plus 1 plus 1, here 6 minus 3 minus 5. So student, here A inverse is minus 2 1 2 1 minus 1 1 1 6 minus 3 and minus 5. This is inverse matrix. So student, it is very important condition for inverse matrix. A is non-singular. A is non-singular means determinant of A is not equals to 0. So A is non-singular matrix. So I hope that student, you are clear. So see you again in next class. Allah Hafiz.